Hi folks, in this video we're going to look at the calculation of the work done and the net work done. In the example here, it says Linda applies a force of 120 to pull the crate with a mass of 50 kg over a distance of 5 meter over a horizontal surface. Now the question, it says calculate the net work done if Linda exerts a force of 120 at an angle of 30 degrees on the crate while there's a frictional force of 50 newtons present. If you look at Linda here, is applying a force which is through a rope. It's a tension force. So we have a tension force there at an angle of 30, and there are components of that tension force there, which is the components. It's going to be Tx and Ty there, right? And another forces that are acting on the crate, it's the normal force. Is very important to identify the forces and the gravitational force and the frictional force, and we are told it's present there. So guys, it's very important to understand those forces. So the first thing that I'm going to do, as they want the net work done, I'm going to calculate the force of each, the work done of each force acting on an object. I'm going to start with the work done by tension force, which is Tx. It's going to be Tx. From this definition, guys, it says work done is equal to force delta x cos theta. So I'm calculating from based on that. So it's Tx is equal to delta x cos theta. So the Tx is going to be T cos theta. I'm going to put in the bracket to show it's Tx delta x cos theta. Now we substitute, guys. If you look at the Tx is going in the same way as the crate, so the Tx direction is there and the crate displacement is going in that, so that means the angle between them is 0. Now let's substitute. It's 120 cos 30 times the displacement, which is 5, and cos, the angle, as I said, it's 0 degrees. So if you punch that in the calculator, the Tx is going to be 519,62 joules. It's a positive work. That means the tension force horizontally, it's doing the positive work horizontally. Now let me calculate the work done by the frictional force. It's going to be Fk delta x cos theta. And then the frictional force, as we're told, it's 50, and the displacement is 5 times by 5 and cos. And remember, the frictional force is going in an opposite direction of the displacement, and the displacement is going there. So if they're going in opposite direction, that means their angle between them is 180, and cos 180, guys, it's negative. This will be negative. So 50 times 5, it's 250, so it will be negative 250 joules. Just punch that in the calculator. So the frictional force is doing a negative work there, so that means the energy has been removed. Now I'm going to do the work done by the tension force that is vertically. So the tension force that is vertically, guys, it's the tension force vertically, and the displacement, it's there. So the angle between them, it's what? It's 90 degrees. Same as the normal force. The normal force is doing normal force, and the displacement, the angle between them is what? Is 90. Same as the gravitational force. The gravitational force, the displacement is going in that way, and the gravitational force x perpendicular there. So the tension force of the work done by the tension force vertically is 0, and then the work done by gravitational force is what? Is 0, as well as the work done by the normal force is 0, because it's cos 90, or you're going to substitute cos 90 there. Cos 90 is equal to 0, so it will make 0 the work done. Now let's do the sum of the work done. So it's the work done by the tension force horizontally, work done by the frictional force, work done by the gravitational force, work done by the normal force, work done by the tension force vertically. So the work done of the tension force horizontally, the horizontal component, it's 519,62, it's positive, and plus the work done by friction, it's negative 250, plus the work done of gravitational force is 0, work done of the normal force is 0, work done by the tension force vertically, which is the vertical component, is 0. So when you punch that in the calculator, the work net there, it's going to be 269,62 joules. So that's the work net there. Guys, let me show you an alternative when you use the F net to calculate the work net using the F net. Guys, the F net of the horizontal forces that are acting there, it's Tx, and the what the T is the frictional force. These are the forces that are doing work there. The vertical one, they're not doing work. So the F net there is equal to Tx is going in the positive direction because it's going to the right, and the friction is going to the left. It's going to be like that. So the Tx, guys, is going to be T cos theta minus Fk, and then the tension force is 120 cos what 30 minus 50. The frictional force is 50. So when you punch that in the calculator, to get that no, what is that, the F net, you get 53,923 newtons. That's the net force of the forces that are doing work there. So let's calculate the net work done, which is the net work done, guys, is the work done of the net force, right? Guys, since the net force is positive, the answer there is positive. That means it's going to the right. F net is going to the right, and the displacement is going to the right as well. So that means the angle between them is 0. So the F net is 53,923, and the displacement is 5, and the cos what? Cos the angle is 0. So the answer will be the same with that one. It's going to be 269,62 joules. So if the F net, guys, it's in the same direction as the displacement, that means the object is what? Is speeding up. That means the object is moving faster. I hope that makes sense.